All right, so this should be where I left off. I had to redo the problem because I'm having problems with the new laptop, so I'm charging. I think I got that fixed. So this should be the work I had left. The last thing I had to do was plug some stuff in. I am letting time be 249, goes there, goes there. The amount in 249 years is going to be 0.01 times 1.1 to the 249th power. And it's going to be a big number, more than you think. We have 0.01, 1.1 to the 249th power. A lot of money, isn't it? Look at that. 202 million. 202 million. 664,930. 220,664,930.6. I'm really, I unscrewed that up, didn't I? 202. New laptop, new software. It'll take me a while to adjust here. 202 664,930. 664,930, and then it's money, so 60 cents. That's a chunk of money. That is a huge chunk of money. $202 million. Ah, the most powerful, and this is a quote, I'm not sure who came up with it. Probably an economist of some sort, but it's a quote. Why isn't it typing? There is no greater force than compound interest. Because of what happens. A penny becomes 202 million. Granted, that's at 10% interest. So there you go. An investment doubles every 12 years. If 3,000 is invested now, what will the investment be in 100 years? Pay attention to the every. I don't talk about this like I should in your notes. Now I may need to remember to add one into there. Doubles every 12. Normally you've got this form. I don't know why I can't move that up. Oh, wrong button. Now the every 12 changes t into t over 12. So it's just something to be careful about because it doesn't happen every year. It happens every 12 years. It's a compounding idea. We compound interest every 12 years. And that has always been an issue for kids to wrap their minds around. But if you see that word every, it's a dead giveaway. But you change that exponent into a fractional exponent. And we're just going to plug in some stuff. I can read, so I notice the principal is 3,000. I'm going to double. So this is going to surprise you, but if you double, your rate of increase, and some kids really struggle with this, is 100%. It's not 200%. It's 100%. So R is 1. And the time frame here is 100. So let's plug some stuff in here. The amount in 100 years is the principal of 3,000. R was 1. And the exponent, the time is 100, but we have to divide by 12. Obviously, before I go push buttons on a calculator, I'm not going to ask my calculator what 1 plus 1 is. I guess I could. That's what I'm going to evaluate in the calculator. All right, fire up CMU here. 3,000. And, you know, it said the word double, so there's that 2. You're probably not listening to the audio, so it doesn't really matter what I say here. Everybody complains about how hard Algebra 2 is, and they don't look in the mirror. That's what it became, 967,916.36. Notice I typed it just as I wrote it. And there you go. And obviously this is in dollars, so you're gonna say things appropriately. You're gonna use your commas. We got a dollar symbol somewhere. $sign 967, comma 619 and 37 cents, because we know how to round, and that penny is important. It is important. Doesn't buy you much, but it's important. I'm only gonna do 2 of these. I'm gonna do 12 and 15. I'm gonna leave those for the rest of y'all. Complete factorization of x to the 6th, y to the 6th. Don't be the kid who only has one line, whatever. Every year I see kids give me back number 12 in one line. That just tells me that they just blindly copy or they use Photomath. They didn't even pay for the good stuff that shows you how you get the answer. Because all that matters is the answer. I'm going to hit this with this pattern first. What I have here is I have x cubed squared minus y cubed squared, which becomes x cubed minus y cubed times x cubed plus y cubed. Then I'm going to factor each one of these. Here I have a is x, b is y, and the same thing here, a is x, and b is y. So each of these actually turn around and factor again. X cubed minus y cubed is going to factor as x minus y times x squared plus xy, because I'm just reading this line right here where my pencil's highlighting, plus y squared. Need a little more room. And x cubed plus y cubed is going to factor as x plus y, x squared minus, because there's a minus, x times y is xy, plus y squared. It's actually not too hard to do, but you know, 99% of the population has to show that before you can show that. This is not a one-line thing. Don't you dare think it's a one-line answer. I got 2 kids who can maybe do that in their head this year, and even then they would surprise me. All right, moving on to 15. The idea of 15 is we multiply the numerator and the denominator by the conjugate, there's that word, the conjugate of the denominator. That's the idea. So the conjugate of 5 plus 3i is going to be, wait for it, 5 minus 3i. So I'm going to do a little work here. 4 times 5 is 20. 4 times negative 3i is minus 12i. Negative 2i times 5 is minus 10i. Negative 2i times negative 3 is plus 6i squared. And fun fact of the day here, I squared is negative 1. Memorize that. So the deal with that was is you change the sign and you get rid of the I squared. 20 minus 6 is 14, and negative 12 minus 10 is negative 22. Now I'm going to work on the bottom here. And on the bottom, the only thing that matters is those two. 5 times 5 is 25. 3i times negative 3i is minus 9i squared. And again, cross, change sign. 25 and 9 makes 34. Now the form here is a plus bi. So I got to think about this as 14/34 minus 22 imaginary seconds of 34. And these are even, divisible by 2, that'd be 7 over what, 17? Yeah, sounds right. Both even, 11 over 17. Final answer. And that is your homework. First homework recorded on the new laptop. It actually worked properly, so I'm happy.